Good morning, dear students. I am Mukesh Kumar Mishra, your chemistry faculty at Aakash, and I welcome you all in the discussion of AIATS plus 2 chemistry question discussions. Okay, so in this session, we are going to discuss about the questions which were asked in the second mock test, okay, particularly about chemistry. So, the plus is a very important series from Aakash. It stands for personalized learning for ultimate success. Very good morning, Dashrath Sharma. How are you? So, I will request everyone to note down each and every concept which I discuss here so that you will be able to recall it later on after the discussion. Today, I am going to discuss about the questions which were particularly from GOC part and hydrocarbon and haloalkanes and haloarenes. So, let's begin. And in the meantime, you can ask your doubt in comment section also. Okay. So, now this first question is, which one is the most reactive towards SN1 reaction? Now we have four options here: C6H5 CS2 C6H5Br, CS3Br, then C6H5 CS3. All these things are there. But to solve these questions, first of all, we have to understand the mechanism for the SN1 reaction. Okay. Now, have a look here that in this SN1 reaction, it actually stands for substitution nucleophilic unimolecular reaction. First of all, I will teach you the concept and then we will move on to the question again now. So, substitution nucleophilic unimolecular reaction. Okay. So, if we talk about alkyl halides, then alkyl halides have carbon halogen bond. Okay. Now try to understand this concept. Carbon is having positively charged and this halogen is having slight negative charge. This is because of the electronegativity difference between carbon and halogen bond. Now, a nucleophile, okay, if we talk about a nucleophile, then nucleophile generally have electrons or they are negatively charged and they are nucleus loving, means they will attack at those positions where positive charge is there. So out of carbon and halogen, where you can find the positive charge on the carbon, so a nucleophile will definitely attack on the carbon. Okay, and now here comes the two type of reactions. First one SN1 and second you also know that SN2 is there. Now this attack can take place via two mechanisms. One of them is SN1. Okay. So after this nucleophile will attack this carbon and then it will form bond with it and halogen will be removed subsequently. But how it happens in SN1 mechanism, this we are going to understand first. Okay. Now let's have a look. So first of all, in SN1 mechanism, what happens that halogen bonds break. Okay. Now try to understand this fact. See, carbon halogen is there. Okay. And this halogen is more electronegative, and as it is more electronegative, it will attract the shared pair of electron towards itself, and this will lead to the formation of carbocation. Okay. Plus X minus is also formed here. So the first step is formation of carbocation. Okay. Now, one thing you have to understand here, that carbon here is sp3 hybridized, and in this case, when this carbocation has been produced, the carbon is sp2 hybridized. Okay. Now, if you want to look at the real mechanism, okay, I will show you one thing here. Suppose we have these three bonds. Okay. This carbon, okay, and then we have one halogen. Okay, like this the bond is there. You can see tetrahedral structure is there. Now what will happen that once the nucleophile attach, before attacking nucleophile, once this halogen is being removed, okay, now what will happen? The bond will become planar. Okay, so this type of planar structure will be produced. Now you can see bond angle is 120 degree here. Now this formation of planar molecule, okay, is a very important concept here, is a very important point here, because now if a nucleophile wants to attack on this, in that case what will happen? See, because of planarity, it has, okay, equal chance from attacking the either side of the carbon. Okay, now try to understand this. See, this planar structure is there. Now what will happen that because this planar structure, the upcoming nucleophile can attack from this portion also, or even from this portion also. Due to this, what will happen? We will show you. See. Now here you can see that this carbon is sp2 hybridized. So during this, in second step, a nucleophile will attack. Okay, and this nucleophile will form bond here. Okay. Now, one thing you have to understand here, that there is certain configuration in this initial haloalkane. Okay. Now, the probability is that the nucleophile can attack on the same side on which the halogen was present, or even on the opposite side. Due to this, what will happen? We can say that a type of racemic mixture will be produced here. Okay, racemization will occur here, but racemic mixture can be produced or cannot be produced. This we will discuss very soon. Okay, so this is the exact mechanism. Okay, it's not always 50-50%. Okay, so you have to understand here. Now, in the question we were asking about the most reactive towards the SN1 reaction. So from this discussion, you can easily see that this SN1 is basically a two-step process. Okay, first one is formation of carbocation, and then second one is formation of the attack of the nucleophile. So this first step, formation of carbocation, is basically the rate determining step here. You all have studied in chemical kinetics also. Okay, that what is rate determining step. So now what will happen here in the next, that we have this rate determining step. First one is there. So the stability, okay, of this carbocation actually decides that which type of, means how fast a reaction will follow, a substance will follow SN1 mechanism. So basically the point you have to note here, that stability of carbocation decides the rate of SN1 reaction. Okay, higher is the stability, higher will be the rate. Okay, and now one more thing we have to understand here, that this type of cleavage, okay, it generally take place in polar protic solvent. Okay, so key points you have to remember, that it is unimolecular, basically depends upon the concentration of alkyl halide only, because this is the rate determining step, and then this intermediate carbocation is formed here. Okay, this carbocation which will be formed in the first reaction will participate again in the second reaction. Okay, now one more important point is that higher the stability of carbocation, higher will be the rate, and then this type of reaction is, this SN1 reaction is followed generally in case of polar protic solvent. Okay, so now let's, in order to solve this question, what we have to do? We have to choose the stability of the carbocation formed. So can you tell which one is, which of the following given compound will form the most stable carbocation? See, suppose if we are talking about the cleavage of this bond, then what will happen? C6H5 CH2 CH2 plus. This will be the carbocation, but you can see it is not in resonance with this benzene ring. Okay, you can see here this plus charge is here, and in between there is a carbon, CH2 hybridized carbon is there. So resonance is not possible. Now one more thing, this will produce, if we remove this Br, it will produce phenyl carbocation. Again, we have already, you already know that phenyl carbocation is least stable. It is generally not formed. Now, this CH3, it will produce this one, CH3 plus, okay? And this C6H5, CH plus CH3. Now try to understand this fact that this one is very important, very stable form here. You can see this carbocation is benzylic carbocation, so it is in resonance, it is getting hyperconjugation from this CH3. So overall stability is, if this one is most stable, as it is most stable, definitely it will be the fastest. Yes, very good GS Aishwarya, that fourth will be the correct answer here. Okay, most stable carbocation has been formed here. Is this clear to all of you? Anyone having any doubt can ask in comment section. Now, but let us quickly recall about the SN2 also, because that is also very important. And one more thing I would like to tell you, that this substitution, nucleophilic and elimination, they are actually competing with each other. Okay, so this thing also you have to remember, that in what case you might have seen in case of Williamson synthesis, sometimes elimination precedes substitution, nucleophilic. Okay, so this thing you have to remember. But let's have a quick recall for SN2. In case of SN2, what will happen? See, SN2 reaction. So this is the second way in which nucleophilic attack can take place. Now here, substitution, nucleophilic, 2 stands for bimolecular reaction. Bimolecular means 2 of the reactant will act simultaneously. One is alkyl halide and another is nucleophile. In this case, what will happen? Suppose again, suppose this is our haloalkane, okay, CH3X, and this one is halogen bond. Now see, instead of this halogen getting removed, what will happen? The nucleophile will attack. Now nucleophile will definitely attack from the region, okay, where less steric hindrance is there. Means here it has carbon halogen bond and the nucleophile has to attack from the back side, okay, because this upcoming nucleophile will be repelled by this halogen only. So this is just a theoretical concept, so you have to understand it like this only. Okay, now what will happen, that if suppose a nucleophile is attacking, then this nucleophile will attack, okay, and due to the formation of this bond, nucleophile, this halogen bond will become weakened, okay, it will start weakening and finally removed. And but during this phase, what will happen? A pentavalent stage will be formed, a pentavalent carbon will be formed, which we call as a transition state. Okay, so transition state and intermediate, there is a difference. Can anyone of you tell? See, in SN1 I called that intermediate carbocation was formed, but here a pentavalent transition state will be formed. So you can see here, this carbon is there and nucleophile. Now this nucleophile will definitely attack from the back side. Okay, and due to this, what will happen? A pentavalent transition state will be formed. You can see both nucleophile and alkyl halide, okay, are reacting with each other here. Actually, yes, simultaneous bond form. Bond is forming and X is getting removed here. El Dorado, sir, मुक्का मारकर halogen को निकाल दो. ठीक है? चलिए कोशिश करते हैं मारने की, ठीक है। तो यहाँ पे पेंटावेलेंट बॉन्ड बनेगा. नाउ व्हाट विल हैपन, दिस nucleophile will become stronger, okay, and you can see here that halogen was and nucleophile, okay, sorry this one is wrong here. Nucleophile is here, halogen is here, okay, and here we have nucleophile will ultimately be here, and now let's draw it like this. Okay, so halogen was attached on this side, was present on this side, and nucleophile will be present on just on the opposite side. So this phenomena is called inversion of configuration. Now this configuration is just opposite to what it was present in the halogen. Okay, never get confused by the optical activity. You should not use words like that. If this given compound, initial compound is dextrorotatory, then this will become levorotatory. Such kind of concepts are not there. Okay, so you just have to think that this inversion of configuration is in relation with the haloalkane that was used here. Okay, so this is all about the SN2. Now one more very important thing you have to understand about SN2 mechanism is that, see, nucleophile has to attack from the back side. Now what will happen, more with the space here, easier will be for the nucleophile to attack. So this generally space problem is called as steric problem in chemistry. If the space is not there, then we will say that steric hindrance is there. So definitely what will happen, steric hindrance is there, so you have to understand this. And due to this steric hindrance, what will steric hindrance in 3 degree, it is most, okay, 2 degree and then 1 degree. So because steric hindrance is maximum in 3 degree, definitely the rate of SN2 reaction will be least because more crowding will be there. Okay, so rate 1 degree will have maximum, because if see only 1 carbon is there and 2 hydrogen are there, in that case what will happen, it will become easier for nucleophile to attack. In case of methyl, it will become more easier. So that's why rate in SN2 reaction becomes 1 degree, then 2 degree, and then 3 degree. I hope this thing is clear to all of you. Anyone having any doubt in SN2 mechanism? You can ask, or we'll move to the next question. No doubt? Okay. So now let's come to the next question here. Now this question says major product B of the reaction is benzene react with CH3Cl anhydrous AlCl3, it forms A, then CH3COCl and anhydrous AlCl3. Okay, very good Karunya. It has formed B. Now this is the aromatic compound benzene, okay, and it is undergoing Friedel-Crafts alkylation and Friedel-Crafts acylation. Okay, is this clear? So one thing we have to understand about benzene or aromatic compound is that they do not undergo addition reaction under normal condition. Okay, so in normal condition what will happen, that aromatic compounds are very stable, and if suppose I am just drawing benzene here, see, you can see here that in normal condition, if suppose it undergoes addition, it will lose its aromaticity and it will become less stable. Therefore, aromatic compounds do not undergo addition reaction easily. Okay, good morning Sopan. Instead, what they will undergo? They will undergo electrophilic substitution reaction. Why electrophilic? Because this bond, these pi electrons are actually present above the plane. You can see here. And this electron cloud, we can say that it is somewhat exposed. Okay? Good morning, Dikshant. So because this pi electron cloud is a little bit exposed, it becomes easier. They are prone to be attacked by electrophiles. So an electrophile, an electron-loving species. In the previous question, we are talking about nucleophile, and if in this case, we are talking about electrophile. So electron-loving species will find it easier to attack these exposed pi electrons. Okay? So now let's have a look at the mechanism. So first of all, before solving this question, we are going to understand certain key points which are necessary, because let me tell you one thing. If you just change the reagent, if you give pass CS3COCl anhydrous AlCl3 here and CSCl3 in presence of anhydrous AlCl3 on second step, the answer will change. Okay? So in order to solve question like this, you have to understand the mechanism properly. Okay? So now here we have to understand one thing, that electrophilic substitution reaction. See, now suppose we have benzene. Okay, so the first step is generation of electrophiles. Okay, generally we are talking about chlorination, means halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Okay, so in that case what will happen? The first step is generation of electrophile, and suppose we are talking about Friedel-Crafts alkylation. So what will happen? This CH3Cl in presence of AlCl3 will form CH3 plus. Okay, this carbocation will be formed, and AlCl4 minus. Okay, now during acylation, this CH3 C double bond O Cl will react with AlCl3. Okay, and then this will form CH3 C double bond O plus AlCl4 minus. So this is how electrophiles are being generated. Okay. Now suppose chlorine is there. Okay, during chlorination what will happen? Means in AlCl3 or plus AlCl3, what will happen? They will form Cl plus AlCl4 minus. Okay, nitration is also there, where we mix concentrated H2SO4 and concentrated HNO3. In that case what happens? That NO2 plus is produced, and that NO2 plus act as electrophile in for further nitration. Now what will happen? In second step what happens? These electrophiles will attack of or electrophilic attack. Now what will happen? You can see here. Just have a look here. We have discussed that this pi electron cloud is actually exposed. Sir, please tell me few chapters of chemistry. Then I got 100 marks in chemistry NEET, please. You can get 100 marks in chemistry boards, but you have to get 180 marks in chemistry NEET. Okay? And in order to get 100% marks in chemistry NEET, all the chapters are equally important. Okay, Rohan? Easy chapters. Whatever is being teased here, just follow that, and after that, after the discussion, if you note all these points, okay, whatever points you note in your class, all the things will become easier for you. Okay? So everything is easy if you know the answer, and nothing is easy if you don't know the answer. Yes, Rohan? Okay, now let's come to this question. You can see here that electrophiles, they have positive charge. Positive charge means they lack electrons, and they will try to get this electron. Suppose we are talking about CH3 plus. Okay, now what will happen? This will form bond. Okay, because this is electron deficient, this pi bond, will move towards the CH3, and due to which what will happen? This carbon will develop positive charge on itself. Okay, now you may argue that, sir, again it has lost its aromaticity. Yes, it has clearly lost its aromaticity. Okay, and then we can see here that, but this is still in resonance, so a little bit of stabilization is there, that's why it forms. But because one hydrogen is also here, one thing you have to understand, and this hydrogen is still present here. Okay, so now what will happen, that this hydrogen will donate its electron, so that this ring will again regain its aromaticity and stability. Okay, I will take doubts after this discussion, so be here and keep on noting everything which I am discussing. Okay, now what will happen, this H plus will again move here. This hydrogen will donate its electron, this bond will break, and this will be the product, and H plus will be removed. So loss of proton also takes place again. So now try to understand one thing here, that during this electrophilic attack, it is very important that substituent groups which are now attached to benzene ring, they will actually direct the further electrophilic addition. On that basis, we can divide it in plus R, minus R, okay, or ortho-para directing or meta directing. So generally you have to understand that if a group is there, if it has greater capacity to donate electrons, okay, so they will donate its electron, and in the resonance you can find it out that actually electron in the density increases at ortho and para position. I will show you an example here. Suppose OH group is there. Now the lone pair of electrons, okay, now this lone pair of electrons will move in this bond formation, and a number of resonance structures you all know how to draw, okay, and then what will happen, you will actually find that electron density increases at ortho para position. Okay, suppose a group which is attached here. Yes, Karunya, very good. It is OP directing. Suppose NO2 is there. Now, in this resonance, this will move here, this will move here. Ultimately, positive charge will develop at ortho and para position. Okay, Ishani? So in that case, what? I will tell you a trick. Okay, so be here. So this is actually meta directing. Now, while solving this question, if you have to find out that which group is ortho-para directing and which group is meta directing, so a simple trick is there. If the direct group which is attached to the carbon in the benzene ring, if it has negative charge, like phenoxide ion, it has negative charge, okay, or lone pair of electron, then in that case it generally becomes ortho-para directing. Okay. For example, ortho-para directing. Examples of ortho-para directing are OH, CH3. Now see, they have single bonds. Okay, so still they have tendency to donate electrons. CH3 is there. Halogens are there. Halogens are slightly deactivating in nature. Okay, but they have lone pair of electrons, so they are also ortho-para directing. Okay, then NH2 is also there. Okay, OCH3 again, this will also be ortho-para directing. Yes or no? Because oxygen has lone pair present on it. Okay, but what about meta directing? So if the group which is attached to the benzene ring, if the atom, just look at the atom which is attached to the benzene ring, if it has double bond, as in this case, NO2 group is there, positive charge, okay, so such substance, such substituents, they actually direct towards meta position. Okay, so meta directing में NO2, C triple bond N, COOH, if carboxylic acid is there, then C double bond O will be there, CHO. Okay, then we have C double bond O, R. So all these groups, they are actually meta directing in nature. Now we have to come back to our question, then we will be able to solve that. Yes, Tejas. Ortho-para means plus M. Yes, simple it is. But one more trick. The trick is that if the group which is directly attached to the carbon contains lone pair, negative charge, or all bonds are single, in that case, you can very easily find out that it is going to be ortho-para directing in nature. Is this clear? And if it has double bond, then definitely it will move towards meta. Now, let's come back to our question. Okay, so CH3Cl anhydrous AlCl3. First of all, we are reacting this. In this case, what will happen? This benzene CH3Cl AlCl3. Okay, so what will be the product here? Can any one of you tell? Write in the comment section. We have just discussed the mechanism of this. What will be the name of compound that will be formed here? Direct Friedel-Crafts alkylation. Okay, so it is toluene. Now this toluene, Jaydev Adhikari, 4th. Okay, now let's have a look. This toluene CH3 group has ability to donate electrons. Okay, so because of this electron donating nature, it becomes ortho-para directing. We have discussed it. So again you can see this CH3 C double bond O Cl and anhydrous AlCl3. It is undergoing Friedel-Crafts acylation now. Okay, acylation. So we can say, and out of this ortho and para, can any one of you tell that which one will be the more major form out of ortho and para? In majority of the cases, you will find that, yes, write in the comment section, Jaydev, Dikshant, Ananya, Karunya, Aishwarya, Tejas, I want answer. Out of ortho and para, which will be the major product? Yes, para is having more symmetrical structure, so it has been observed that in most of the cases. Okay. Yes, Cassie, in general trend we say that meta directing compounds actually they withdraws electron from the benzene ring, so they are deactivated because product yield is very less in that case. Okay. So yes, Very good, Rutuja. It is para that will be formed here. CS3, CO, CS3. So this will be the product here, and fourth will be your answer. But now, again the same question is there. Yes, steric region is also there. If I exchange this reagent, then what will be the product? Will your answer change or it will still remain the same? Yes. We have exchanged the reagent. First of all, we are using CS3, COCl and HydroCl3, and after that we are using CS3Cl. Now, still you will be getting this fourth, or answer will change here now? Yes, write in the comment box. Please be quick. Aishwarya says, sir, same answer will be there. That's why I have told you to note down each and every concept which I discuss. Anyone with Rakesh says, sir, it will change. But okay, if it will change, then what will be the correct answer? Is that Karunya different? Okay. What will be the answer then? So first of all, if Friedel-Crafts acylation take place, then what will be the product here? COCS3? Yes, Joy, you are very good. Exactly. See, again I have told you that if the group that is attached to the benzene ring contains double bond, then you have to think that, okay, it will go for meta position. We have discussed it right here. See, this C double bond OR is meta directing in nature. Okay? That was the trick actually which I wanted to discuss. That's why I have discussed it. Okay? Now this is meta directing. So if the Friedel-Crafts alkylation take place now, yes, Aishwarya, you made a silly mistake, but it's okay. The more mistakes you commit here, lesser will be the chances of repetition again, if you revise them accordingly. So C double bond O CS3, and finally, after Friedel-Crafts alkylation, it will form CS3. So in that case, third will be the correct answer. See, meta position, they both are on meta position. Okay, 1,3, 1,3 position. Don't get confused that, sir, see, you have written CS3 here and COCS3 is here, but in that case, if you look at the IUPAC nomenclature, you'll find that both are same. Okay? So this is how we actually deal with such kind of questions. If subsequent electrophilic reactions are there, then you have to find out that, okay, the group that has been attached to the benzene ring is whether ortho-para directing or meta directing. Okay, is this clear to all of you? So now let's move on to the next question. Which among the following is most reactive towards electrophilic substitution reaction? Now, most reactive. See, one student also asked the doubt that, sir, whether if it is meta directing, then it is deactivating or not. Okay. Generally, in case of meta directing, product yield is not that much, because it's not actually because of the exact electron density which has increased at meta position. Okay, Karunya says crystal clear, sir. Yes. Now see here. So we have to look, if we want to find out that which of the given substance will undergo electrophilic substitution reaction fastest, at that time we have to think that, okay, in which condition, benzene ring will have the maximum electron density, and definitely that compound will be our answer. So halogen, first of all, let's talk about halogen. We have discussed that halogens are ortho-para directing. Cl is actually ortho-para directing. But what happens? Okay, that Cl has electroinductive effect also. Okay, so the tendency to donate electron and the inductive effect, they are actually working against each other, due to which what happens that in case of halogens, generally product yield is not that much. So that's why halogens are mostly deactivating in nature. So less product will be there. So this will not be our correct answer here. Now let's talk about CHO. Again, CHO is meta-directing, and it actually withdraws electrons from the benzene ring. Again, there will be lesser amount of electrons on the benzene. So this will not be the correct answer. Now CH3 and CH2, CH3. Out of this, CH3 means toluene, means CH3 group, and this ethyl group. You will find that methyl has more tendency to donate electrons. So there are inductive region, hyperconjugation region, all are there. So but the electron donating effect of this CH3 is greater than CH2, CH3. Okay, so this will be our correct answer. Is this clear to all of you? This is how we find out that which substance will show the maximum tendency towards electrophilic substitution reaction. Pramukh has asked some question. Sir, NHCO NH3 is meta-directing. NHCO NH3 is meta-directing. No, it's not meta-directing actually. Okay. What will happen in this case? Nitrogen will show the tendency to donate electron still. Okay. But the amount, because the lone pair will be present in the conjugation with this C double bond, so very less tendency will be there. Okay. Very less amount of product will be formed there. Now let's come back to the question number 75. Among the following, which bromide will react fastest with AgNO3 solution? Yes. So if we talk about this question, then again we have to find out that suppose Rx is there, what actually happens here. Rx react with AgNO3 and what will happen? Okay. AgBr will be formed here and it will precipitate out. So again, generally here the formation of carbocation will take place. Okay, Shayan? Yes. So this formation of carbocation again is very important concept here. The more stable carbocation will be formed, the more will be the tendency of halogen to leave the group. So here you can see that if Br leaves, then this carbocation will be formed. Now let us draw the carbocation formed, one by one. This carbocation will be formed here. Okay. So can any one of you tell? Tropanalium carbocation. Tropalium carbocation is there, yes. So can any one of you tell that which one is the most stable carbocation here? And what is the exact reason for that? We can see this carbocation is in resonance. So resonance stabilization is there. Again, this one is also stabilized by resonance. Yes or no? So, but here stabilization is more. So in respect to this first, fourth will be the more stable. Okay, everyone is saying 2. So just give me the reason. Yes, Pramukh. Very good. So aromaticity is the reason here. If we talk about this third, you know what is happening here? If you go to the last lecture, you know, in that case lecture I have discussed about aromaticity in detail, that how we can find out whether a given compound is aromatic or not. Okay. So what are anti-aromatics and what are non-aromatics? In my previous lecture I have discussed it. You can again go back to the very important series is there by Pankaj sir about GOC, Kataj, you know, you can check in the playlist. In that case he has also discussed the complete GOC, so there also you will be finding the complete discussion of aromaticity. So don't worry about that. If anyone has any doubt, then they can, you know, follow those 2 lectures. So here, that's why I am just having a quick recap here. This one is anti-aromatic, and anti-aromatic substances are very least stable. So third will not be the answer here. But if we talk about second, definitely this compound, it is troponium carbocation and it is aromatic in nature. And due to this aromatic nature, it is most stable and most easily the bromide will be lost and it will give the precipitate. Anyone having any doubt now in this question? Okay, now let's move on to the next question. The most stable carbocation among the following is? So GOC is full of these kind of concepts. Yes. So in order to find out the stability of carbocation, you have to look for hyperconjugation, resonance. Okay, they are actually the stabilizing effect. Okay, stabilizing forces. So yes, please tell. Yes, I want answers. You all have attempted these questions. The most stable carbocation among the following is? Now Pramukh says, now GS Aishwarya is saying sir 4th, Casey and Pramukh are saying 3. Now again Uttej is saying 4, 3. This is the very good situation here, 50-50. Animesh Day 4th, Joy Dua 4th. So some of the students, you know, they want to say that okay, 3rd is the correct answer. Hema Malini Shetty again 4th, Rakesh, Animesh Day is in class 10th. Okay, very good. So some of you are actually you know, going for this 3rd option, and some of you want to say that okay, 4th will be the correct answer. Now let's have a quick recap here. If we talk about this, this is, you know, actually vinyl carbocation, and we know that vinyl carbocation, it is neither stabilized by resonance or nor, you know, hyperconjugation, so it is least stable. We will not talk about this. Okay. Now if we talk about this, then it has resonance is not there. Yes, R means resonance, so resonance is not there. But if we talk about hyperconjugation, then 3 and 1. 4 hyperconjugation is there. Pramukh says it's 4. If we talk about this 3rd one, it has resonance. Okay. So resonance effect is very much here. And if we talk about this 4th one, then it has resonance is not there, but 3 plus 3 plus 3, 9. 9 hyperconjugation are there. Now, okay. So one very interesting fact, everyone please note it down, that generally we consider that resonance dominates hyperconjugation. Yes or no? So it is general case. But on the basis of observation, it was found that if 9 hydrogen are there for hyperconjugation, so it will dominate the resonance effect of the benzylic carbocation. Okay, is this clear? So because of this, you know, tert butyl carbocation becomes most stable. This is an exception. Those who were answering, we are going for 3 and they have learned the order that okay, 3 degree means benzyl carbocation is more stable, followed by 3 degree, 2 degree, 1 degree. So that is correct. But this is another exception, or we can say another different case, which you have to remember, that tert butyl carbocation is more stable than benzyl carbocation, and this is because of the effect that 9 hyperconjugates, they actually dominates the resonance of benzylic. Is this clear to all of you? Yes. Now what will be the answer? Definitely fourth. Okay. Now let's move on to the next question. Okay, tell me one thing. Hyperconjugation is, yes, very good Karunya. Hyperconjugation is permanent effect or temporary effect? What's your opinion? Hyperconjugation is permanent effect or temporary effect? Such kind of questions are also asked, that which effect is temporary, which effect is permanent. Exactly, very good. It's permanent effect, that's why it is actually affecting the stability. Yes, permanent. Okay. In fact, resonance is also a permanent effect. So both the effects that were involved here are permanent. Yes, electromeric is temporary. That actually takes place in, yes, very good Malik Surya. Now this is the part of chromatography. So question number 59, it says that consider the following two statements. Statement 1, paper chromatography is a type of partition chromatography. And statement 2 says that thin layer chromatography is a type of adsorption chromatography. Okay. So during partition chromatography, what happens that, continuous mobilization, mobile phase is there, and, that actually helps in the separation of the different compounds. So therefore, partition, Nidhi Basan is saying, sir, option 2 is correct. Exactly. Paper chromatography is a type of partition chromatography. Okay. Now let's talk about thin layer chromatography is a type of adsorption chromatography. This thing is also, correct. Differential adsorption is there in adsorption chromatography. So thin layer is correct. Okay. Yes, Nitil. Both statement 1 and statement 2 are correct here. Now this is a very interesting question. The most suitable reagent for the following conversion is, yes. What will be the correct answer here? Alkyne is there. Okay. Alkyne is there, and then you have to make trans alkene. Yes. So we all know that this Lindlar's catalyst. Lindlar's catalyst, again, it will produce the same, but it actually produces the cis form. It is not the trans. Form is very important here. Okay, exactly. Sodium in presence of liquid ammonia, so trans. Okay. Do you know the product that will be formed in the second case? Yes? In second case also, B2H6THF in presence of acetic acid also, it will form the, cis product only. Okay. So this thing you have to remember. So trans we have to form that, option 3 will be the correct. And during hydration, we all know that what will happen, alcohol will be formed, but that will tautomerize to give ketone. Okay, so this was the complete discussion related to the GOC part, haloalkanes, haloarenes, which were asked in mock test 2. Now this is the end here. Anyone having any doubt? So be here in the next for the next session. It will be taken by another sir with some new questions which were asked in the exam. Till then, have a great day.